All right, welcome back. So last time we talked about how to write about a figure and a little bit more of the components of the ggplot, and that we talk about our hypotheses. Whenever we're writing about the figure, we orient the readers to the graph. We restate whether or not the hypothesis, the data seem to support or refute the hypothesis, or perhaps it's inconclusive. And then we comment on outliers as necessary. Often these outliers are what are the seeds to future research. And so in this case, we see that we've got these 5 points that kind of don't follow the rest of the trend. And so we want to come up with hypotheses about these, and we would want to test these hypotheses graphically or statistically or with some other means. So some hypotheses could be like, oh, perhaps the vehicles are hybrids, or perhaps they use diesel fuel instead of regular unleaded gasoline. Or maybe it's just that these 5 cars are newer and therefore they're more fuel efficient for whatever reason. So when we go to test these hypotheses, um, the idea here would be like, well, if somebody says, oh, these outlier cars are hybrids, well, there's not a lot of hybrid cars that were in production in both 1998 and 2008, or honestly, there weren't even very many hybrid cars in production in 2008 at all. And these cars would have been classified as perhaps subcompact or compact. And again, this goes back to one of our very first lessons that data science is the intersection of domain knowledge and statistics and code. And so this is where it would be critical to have a domain expert on your that knows this data set very, very well to say, well, hold on, you're trying to ask about hybrids, something that wasn't measured in your data set. And I see this happen with students in public health all the time. They have a question that they want to answer. They have a data set that was collected by someone else, some secondary data, and they say, I'm going to bend this data set to my will so that I can answer this question that I care about. When in reality, when the data was collected, they never measured anything related to what you're trying to answer. So it's important to understand the limitations of your data and say, all right, well, let's find out what our data can say and what our data cannot say. So hypothesis one, we can't even test whether or not those cars are hybrids at all. But we could get a little bit close. We could say, okay, well, maybe these cars are subcompact or compact. And so we would build a figure here, and we see then that most of these cars, that what is it, 5 of the 6 cars in this cluster fit in the two-seater category. Now that's interesting because there's not a lot of hybrids that I know that fit in this sort of two-seater coupe category, if you will. Um, Now I'm not going to belabor this point, but what I want you to do is after this video is over, go back and write the code necessary to make this graph. And that's the same for the other hypotheses as well. Now, what's interesting though is when we get to hypothesis two was saying, well, maybe it's that these cars take diesel. Well, we do see that all of these cars take the exact same kind of fuel, but that is that they are premium. They take premium fuel. Now, this is interesting. So when we take this information that all 5 of these cars take premium in conjunction with the fact that all 6 of these cars take premium, in conjunction with the fact that 5 of the 6 cars are two-seater coupes, well, now we start to get an understanding, like an image of what kind of car this is. But we still had another hypothesis to test, so let's move forward. And again, these exercises, work them on your own time once the video is done. The third hypothesis was, well, maybe it's that these outlier cars are all newer, but we see that no, not really. I mean, some of the cars are from 2008, and well, four of the 6 are from 2008. 2 of the 6 are from 1998. Maybe there's something here because 4 of the 6 are younger, but I honestly think that we're getting much better traction identifying the fact that they take premium gasoline and that they are two-seater coupes, except for this one right here. This one is listed as a mid-size. And so maybe this is some larger car. It seats 4 people, but the engine is still a priority. So from this information, we would say, well, honestly, it seems like this is we're dealing with sports cars. And so that's what we're talking. We would update the hypothesis to say, okay, we've got sports cars. That's what we're dealing with. So sports cars, they're taking the premium fuel and they're two-seaters or at least a larger engine body, whatever, so forth. And so we see right here that this is honestly pretty good discrimination. We're able to separate discrimination in the statistical concepts means separation. We're able to separate these points out and say, yeah, I think we're actually explaining what's going on pretty well, that these are probably sports cars. So again, exercises here. So I want you to think about this graph. I want you to create this graph on your own, and I want you to create this graph on your own as well. And then finally, I would say, okay, if you're thinking to yourself, I wish there was a way to clean this up, to show the premium fuel two-seater car. So to look at this and say, okay, well, are there other cars that we're missing that are two-seater coupes that also take premium fuel, or are they all right here? And we've got a really good understanding of what's going on with this. Well, in order for us to do that, we're going to need some additional functions that we won't learn yet. We will not learn them until lesson 9. We'll need some functions out of the dplyr package. So once you have lesson 9 under your belt, then you can come back to this figure and we can find the best way to sort of discriminate or split out these 6 points here from the rest of the data set to understand what's going on with them, what makes them special. Why do they have such good, comparatively good fuel economy given their engine size? All right, so that's about all. That's what I want to talk to you about as far as aesthetics, and then geometric objects. So there are a lot of geometric objects. We started off with geom point, though, but we could have done something else with this data. We could have instead done a smoothing spline. And if this is what we wanted, then we would build a smoothing spline that looks like this, and it does show the relationship between the engine size and the highway economy. But again, these outliers are really doing a number on our graph, because all of a sudden these 6 cars over here, they are starting to bend this entire relationship to say, hey, you know what? Maybe as the engine gets bigger up to a certain point, it's bad for the fuel economy, but then after that point, it starts to get good for the fuel economy again. And that just, like, in terms of like physics and understanding the data, again, domain knowledge is helpful to have, very important to have. We know that this is probably not, this is like a spurious relationship here in the data. And it's almost entirely driven by these 6 points up here that are way higher in fuel economy than they should be, given how large the engines are. And so this is with geom smooth. And then I can kind of add all these things together. And I can say, okay, well, here I've got my data layer. And then I'm going to map my aesthetics layer. So I'm going to put on the x-axis displacement, on the y-axis the highway fuel economy. And then I'm going to add, if I wanted to, the color of the figure to be the cylinders, like how many cylinders do the cars have. And I can see here, there's a strong relationship between the number of cylinders and the displacement of the car. So obviously, as the larger the engine is, the more cylinders it's likely to have. But that doesn't really have a noticeable effect on the highway fuel economy. But we've just added this comparison in as well. And then we also added the default smoother, which is something called a low S smoother. And that's this blue curve right here. And then we also added a smoother in red, and that's the linear trend. So LM is for linear model, just a straight line. And we can see that as far as the straight line is concerned, that the bigger the engine is, the worse off your fuel economy is. So, and again, I have a comparison here. Notice that we are comparing the relationship between engine size and highway fuel economy while accounting for the effect of the number of cylinders and also overlaying 2 smoothers, both a linear smoother and a low S smoother. But you can imagine that this is 5 lines of code right here. There's 1 comment here, so 6 total lines, but 5 lines of code. And if I wanted to keep adding more and more and more and more and more onto this figure and and keep adding these modifications. I totally can. And there's times where you get ggplot code for like a really fancy figure that you make, where the ggplot code is potentially 80 or 90, sometimes longer, 80 or 90 lines of code long. And each line is important, and each line helps add a little bit more to the story or make the graph seem a little bit more formal and presentable. Because we see right here the number of cylinders. This is not formal. DISPL and HWI and CYL. There's no title here. There's a lot more that needs to happen to this graph. And so each time that we have to make modifications and changes to the graph to make it better for a journal that we're submitting to, then that's going to be another layer that we add on. Speaking of labeling your graphs, I think this is we'll pick up labeling your graphs in the next video. So this will be a good place to pause, and I will see you shortly.